Hey there, 7th graders, and welcome to today's Explainer. We're about to pull back the curtain on artificial intelligence. So, the exact title for our session today is Machine Learning, Evidence Discussion Video Overview. And for those of you keeping track of the curriculum, our specific lesson ID is STEM TI, STEM AI, Unit 04, Lesson Pack 04, Machine Learning Evidence Discussion Video Overview. I know, right? That is a huge mouthful, but it basically boils down to one super important thing. Today, we're figuring out how to actually evaluate the AI systems we interact with every single day. We're going to learn how to spot the difference between an AI that just sounds really smart and an AI we can actually trust because it's backed by real evidence. Let's get right into it. Here's our roadmap for today. We'll start with Section 1, the Fluent AI misconception. Then, Section 2, finding real AI evidence. After that, Section 3, checking a classroom AI. And we'll wrap up with Section 4, your turn, transfer task. All right, Section 1, the Fluent AI misconception. Subtitle, Big Idea 4, Natural Interaction. So I want you to really think about this for a second. If an AI sounds perfectly human, does that actually mean it's accurate and trustworthy? Think about the chatbots you've messed around with, or the voice assistant on your phone. You know, they say hello, they tell jokes, they use flawless grammar, they just sound so incredibly friendly. Because of that, it's so easy to fall into the trap of thinking, well, if a computer talks exactly like a smart human, it must actually be smart, right? It must be correct. But is that really true? Well, the short answer is no, absolutely not. And honestly, this is one of the biggest traps in technology today. It's a huge misconception to assume that just because a natural interaction system gives you fluent conversational replies, that its underlying machine-learned model is actually accurate. See, sounding fluent and human, that just means the AI is really good at mimicking our language. But being accurate and trustworthy, that means the machine learning model underneath the hood is actually giving you factual, safe information. They are two totally different things, guys. Fluency is just a cool feature. It is definitely not evidence of the truth. Moving on to Section 2, Finding Real AI Evidence. Subtitle, How Experts Evaluate Machine Learning. Okay, so if we can't just trust a friendly chatbot's voice, what exactly can we trust? Well, to figure out what counts as real evidence, we've got to look at how the experts do it. According to the experts at OECD.ai, modern systems rely heavily on something called statistical AI. Basically, instead of humans sitting there programming every single rule, machines actually deduce a trend from a massive set of patterns. They learn through trial and error by crunching enormous amounts of data. So because these systems rely entirely on massive data for their training and evaluation, the real evidence of an AI's trustworthiness is actually hidden right there in the data itself, not in how nicely it talks to you. And to help us put that into practice, the National Institute of Standards and Technology, or NIST, created this amazing AI risk management framework. They give us these 4 core functions to evaluate AI trustworthiness. It's essentially our ultimate evidence checklist. Step 1 is govern, which means setting up the rules and figuring out who is responsible. Step 2 is map, which is all about understanding the context and the exact data the AI uses. Step 3 is measure, where we actually test the AI to see if it's accurate and safe. And step 4 is manage, which is figuring out exactly how to fix risks and errors once the AI is actually out there in the real world. Let's bring this to life in Section 3, Checking a Classroom AI. Subtitle, Putting the Evidence Checklist to Work. So let's take these high-level government frameworks and drop them right into a situation you might actually face in middle school. Imagine this hypothetical system. Your school rolls out a brand new natural interaction AI chatbot that's specifically designed to help you with your 7th grade science homework. You type in a really complicated question about, say, photosynthesis, and boom, it instantly replies with a super friendly, completely natural sounding paragraph. But wait, remember that big misconception we just talked about? We can't trust it just because it sounds fluent. We need real evidence. So instead of just trusting that friendly voice, we run it through our NIST evidence check table. Let's break it down. For govern, we have to ask, who at the school or at the software company is actually responsible for this AI safety? For MEP, we want to know what specific data patterns trained it. Like, did it read actual verified science textbooks, or did it just scrape random internet forms? For measure, we ask, is it actually accurate in its answers when we test it against 7th grade science standards? And finally, for manage, how do we fix errors or biased outputs if it gives a student completely wrong information about a chemical reaction? Getting the answers to these 4 questions, that is how you get real evidence of trustworthiness. All right, Section 4, your turn, transfer task. Subtitle: Apply your new skills. Okay, I'm handing the reins over to you now. Let's see if you can apply what we just learned to a brand new hypothetical scenario. Imagine you download a new AI app. It scans a photo of your lunch, and then it tells you a joke about it. How do we prove this AI is trustworthy? Take a quick second to think about this. And remember, whatever you do, do not fall for the trap of the joke's fluent delivery, even if it's literally the funniest pizza pun you've ever heard. Okay, so if you were thinking about checking the data and using that risk management checklist, you absolutely nailed it. First things first, you have to completely ignore how funny or natural the app sounds. Instead, you'd lean on the OECD principles and check the data patterns. What images of food was it actually trained on? Then you'd map the system's limits using the NIST framework. Like, does it actually know the difference between a real apple and a plastic toy apple? Finally, you'd measure its accuracy and manage the risks. What happens if the app starts saving photos of you and your friends without permission? Asking those questions is exactly how you find the real evidence. Bringing it all together in Section 5, the final takeaway. Subtitle: Fluency does not equal accuracy. If you remember only one thing from today, make it this: trust the data, not the chat. Natural interaction is an incredible technological achievement, for sure, but it's literally just the surface. True trustworthiness requires you to look under the hood. Real evidence comes from mapping data and measuring risks, using those OECD and NIST standards, not from fluent words. So I'm going to leave you with this final thought to carry with you. The next time an AI gives you a confident, natural-sounding answer, what evidence will you ask for before trusting it? Stay curious, think critically, and always demand the evidence. Thanks so much for joining me on this explainer, and I will catch you in the next one.